This is the second video on KSP, which again is just solubility equilibrium. So it's a substance that can slightly dissolve. I skipped the first problem on your notes. This is your notes, but this is exercise 2, the second problem, and it's calculating KSP from solubility. Okay, so they're going to give you the solubility of a compound that's generally insoluble. They're going to say, okay, this is how much can dissolve. You forgot the KSP. Not a difficult problem. So they're giving us a molarity. Now, they could give it to us in grams per liter rather than moles per liter, but we can always change it to that. But this one is in molarity. And when they do that, at this temperature, it is the maximum solubility of that compound. It's the most it can dissolve. So here's the compound we have. The reason I'm doing this one rather than that one is that one's pretty simple. This one has some coefficients involved in it. So we have this compound. Again, that would be as a solid. They're dissolving it in water. They're trying to get it to dissolve in water. So it's going to somewhat dissociate into its ions, although not a whole lot. If you look at the molarity of it, only a small number of these are going to dissolve. So it's going to create bismuth plus 3 ions. And there's going to be 2 moles of those. Again, they will be aqueous. Plus 3 moles of sulfur negative 2 ions. So this is telling you the molarity of those. So for our KSP expression, KSP equals concentration of bismuth ions squared times concentration of S negative 2 ions cubed. These will not be the same concentrations. Okay? They're going to be different in this case. So it's telling you the solubility of this compound. It's saying this is the molarity of this. So if this is 1 molar, that's how much can dissolve. If 1 mole per liter of this can dissolve, this is going to be 2 moles per liter. That's going to be 3 moles per liter. Well, in this case, it's 1 times 10 to the 1 times 10 to the 15th moles per liter. So that's going to be double that. And that's going to be triplet. So if we want to plug into our KSP expression, we can figure out the KSP. So KSP equals bismuth concentration, again, will be double what this concentration is. So it's going to be 2 times 10 to the negative 15th molar. That needs to be squared. Times S negative 2 concentration will be 3 times what this was dissolved. So 3 times 10 to the negative 15th molar. And that needs to be cubed. So take this squared times this cubed. We get a really, really, really small KSP. What that means is a very, very tiny amount of these molecules dissolve and dissociate into ions. A majority of them stay together as molecules. You put them in a beaker, and a huge number of them are going to be sitting on the bottom of the beaker undissolved. A very tiny amount of them, this concentration is going to be dissolved. And again, these are the maximum amounts that can be dissolved at that temperature. At a different temperature, that would change a little bit, but that's the most you can dissolve. You can't dissolve any more than that. You can dissolve a little bit less, but not anymore. So that's giving you the solubility, figuring out KSP. Next thing is going to be the opposite. I'm going to give you the KSP. You're going to tell me what's the solubility in water. So given KSP, that's all it's going to give you. You're going to say, okay, what is the molarity in water? So here's the next one. So this is exercise 3 in your notes. Not a lot of problems in there, but so now we're trying to figure out, okay, we're getting KSP. What is the solubility? In other words, what's the maximum molarity of this compound that can dissolve? How much this can dissolve, because it's a pretty insoluble compound. So first thing, I always show how it dissolves. Okay, every time I make you do that. So, and I don't usually make you show solid, liquid, gas, aqueous, but we're putting this in water. So know what's going on here. Putting that in water, and it's splitting apart into copper plus 2 ions. I didn't mean to put those in brackets. plus some iodate ions, which are IO3 -1. And there is a 2 out there. I forgot to put that out there. So that means for every 1 mole of copper ions, there's 2 moles of iodate ions. So this is giving us the KSP. Okay, it's giving us the KSP. And it's asking us what is the maximum solubility in water. Okay, so maximum solubility in water. Well, if we write our KSP expression, okay, our KSP, I'm going to write over here, KSP equals concentration of copper ions to the first power times concentration of iodate ions to the second power. Again, it would be over this, but this is a solid, so not part of the equilibrium expression. So we're trying to figure out what are these concentrations and what would the concentration of this be that is dissolved. So what molarity of this can this be? So if we think about these dissolving, we're going to plug into the KSP. Okay, we know the KSP. We know it's 1.4 times 10 to the -7. So we can say 1.4 times 10 to the -7 equals, well, if this is X molarity, this is going to be double that concentration. In other words, if 2 moles of this can dissolve per liter, there's going to be 2 moles of copper ions and 4 moles of that. If 10 moles of this can dissolve per liter, that's going to be 10 moles, that's going to be 20 moles. So we're going to make this X, this 2X. So let's plug in here. X for copper to the first power, 2X for that concentration, and that is squared. You gotta be careful here. 2x squared is actually not just 2x squared. 2x times 2x is 4x squared times x is 4x cubed. So 2x times 2x is 4x squared times x is 4x cubed. So we have 1.4 times 10 to the 7th equals 4x cubed. Hopefully your algebra skills are decent. We're going to divide by 4. And then we'll take, that will make those cancel. We'll take the cube root of that and the cube root of that. So if you're using your big calculator, you may have to hit the caret key, parentheses 1/3 for the cube root. Maybe it has a cube root on it. So that'll give us our x value. And our x value there is, sorry, x is 3.3 times 10 to the -3 molar. 3.3 times 10 to the -3 molar. So that is the concentration of copper ions when all of this is dissolved that can possibly dissolve at that temperature. Well, if that's 3.3 times 10 to the -3, that's going to be double it, 6.6 times 10 to the -3. But it wants the concentration of this. Like, what is the solubility of that compound? Well, this is in a 1-to-1 ratio with that compound. So since this solubility was that, the solubility of this is 3.3 times 10 to the -3 molar. Again, that is the maximum amount that can dissolve at that temperature. You can't dissolve any more than that. You can put more in water, but something's going to sit on the bottom undissolved. So, again, if you are trying to find KSP, it will give you the solubility. You plug those solubilities in. If you're trying to find solubility, it will give you the KSP. You put in X's, go from there. 2 different problems. Have a great day. Work hard.